Scope of work for system integrator. Project execution and management. General. This section outlines the basic requirements of project execution for the EPC contract required by the system integrator. The system integrator shall adhere to a detailed project execution plan approved by the company contractor using the principles outlined in the following sections. Project key personnel. The system integrator shall ensure that sufficient qualified personnel are at all times allocated to the project. The project team structure should achieve continuity, quality, and consistency of project implementation. The key personnel include project manager, responsible for overseeing complete project execution, control, and management. Monitors and reports progress, coordinates all project review and design review meetings, acts as the single point interface for project management and control personnel for resolution of any project issues. Lead engineer for instrumentation, control systems, and telecom systems. Leads the team for design, engineering, procurement, and implementation of all systems. Ensures technical correctness during design, engineering, FAT, EFAT, construction, and commissioning phases. Key project coordinator. Located at contractors' offices, the coordinator will work with the contractor company throughout the project. Serves as the single point of contact for all engineering activities. Updates the Project InTools database for all systems, attends all weekly engineering meetings, and is responsible for all decisions and approvals on behalf of the system integrator. Responsibility and work split matrix. The system integrator shall define the roles and responsibilities of all interfaces required between the system integrator, contractor, sub-vendors, and the company. The responsibility matrix shall demarcate the scope of supply and services between all involved parties and form an integral part of the project execution plan. Project schedule. The system integrator shall produce a Level 4 project master schedule, covering major milestones using the critical path method. The master project schedule shall cover engineering, basic, detail, and construction, system design review meetings 30%, 60%, and 90%, FAT of subsystems, IFAT, construction, mechanical completion, commissioning, and startup. This schedule shall be monitored on a weekly basis, with areas of concern clearly stated with action items. It will be used as the basis for progress reporting, controlling, and forecasting. Progress reporting. The system integrator shall submit a fortnightly progress report with critical path analysis, reflecting engineering progress, resource allocation, critical milestones, effective engineering changes, areas of concern. Weekly review meetings. Weekly engineering and procurement coordination meetings will be held at contractors' offices. The key project coordinator will attend these meetings to address all aspects related to the system integrator's scope of work and supply. Design review meetings. Design review meetings are structured to enable early design freeze, expediting procurement and testing, and planning construction and commissioning activities. These meetings are planned by the system integrator and captured in the project execution plan. System Definition Review, SDR meeting, takes place at 30% of design and engineering completion level. Key documents such as the Master Project Schedule, Project Execution Plan, Functional Design Specifications, FDS, for SCADA, ESD, F&G systems, and system architecture drawings are reviewed and finalized. System Critical Review, SCR meeting, takes place at 60% of design and engineering completion level. Detailed design key documents such as control shutdown schemes, logic diagrams, I/O assignments, and software detailed design specifications are reviewed and finalized. System Readiness Review, SRR meeting, takes place at 90% of design and engineering completion level. System readiness for inspection, testing, construction, commissioning, startup, and integration to existing systems is reviewed and finalized. Contract completion, CD dates. The project is to be completed in phases to supply early gas to the consumer. The instrumentation and telecom systems must be ready for operation as per the phased completion dates. The system integrator shall build the project master schedule, considering these completion dates. Change management and variations. All changes during the project execution will be initiated by the contractor company. The system integrator shall follow the terms and conditions of the subcontract change management procedures for requesting any change in scope, supply, and services. Variations. Variations to the subcontract scope of work and supply follow the subcontract variation management procedures. Variation order requests, VORs, must include full technical description of the proposed change, commercial impacts of the proposed change, direct and indirect effects on the current project schedule and completion dates, supporting documentation and additional instructions from the contractor company, unit rates for scope of work and supply. All variations shall be quoted in an aggregate total figure and a unit rate system. This system of unit rates shall cover all aspects relating to the EPC scope of work for the system integrator. Basic engineering and design. General. The system integrator shall endorse the basic design as specified within the functional requirements and architecture drawings for each system. Accepted deviations from functional requirements and bid documents are as per the annexure. Pre-design field survey. Conduct pre-design site surveys for existing SCADA RTU systems, ESD F&G systems, and Telecom systems. SCADA RTU systems. Provide a new SCADA system integrated with the existing system or an extension of the existing system, resulting in an upgraded SCADA platform in terms of hardware and software. ESD F&G systems. Provide an integrated ESD F&G system with high safety integrity, CL3 certified, and availability, 99.99%. The system shall be implemented on a redundant basis and meet the functional requirements for ESD F&G systems. Telecom CCTV. Provide an OTN telecommunication network integrated with the existing network using fiber optic backbone cables and a TCP/IP-based backup system. Interfaces with third-party systems. Ensure the system can interface with third-party systems such as metering systems, burner management systems, HIP systems, UPS systems, and building fire alarm systems. Master Document Register. Provide a master document register for all documents drawings mentioned in the VDRL document. Vendor Document Requirement List, VDRL. Submit a complete vendor document register and ensure the engineering details and content of each document and drawing meet the VDRL requirements. Detail engineering and design. General. Follow all project-specific documents for detail engineering and design. Engineering and design. Prepare key documents, finalize hardware with other system vendors, implement software functional requirements, integrate all systems, and develop rules for interface communications. Project Instrument Database, Smart Plant Instrumentation, SPI. Maintain the project SPI instrument database and update it throughout the project, ensuring all key documentation is generated and updated as required. Procurement of systems and equipment. General. Procure all necessary systems and equipment, ensuring timely delivery and quality. Scope of supply. Include all necessary systems, subsystems, and equipment as part of the supply scope. Spare parts and special tools. Provide spare parts and special tools required for the systems. Inspection and testing. General. Conduct thorough inspections and testing of all systems and equipment. Inspection test plan. Develop an inspection test plan and ensure all systems are tested according to the plan. Factory acceptance test, FAT, and integrated factory acceptance test, IFAT. Conduct FAT and IFAT for all systems, ensuring compliance with project requirements. Construction and supervision. General. Oversee the construction and supervision of all systems, ensuring compliance with safety and quality standards. Site acceptance test SAT. Perform SAT according to the approved SAT procedure, demonstrating system compliance with project requirements. Pre-commissioning, commissioning, and startup. General. Appoint qualified engineers and technicians for pre-commissioning, commissioning, and startup activities. Pre-commissioning and commissioning. Carry out pre-commissioning and commissioning activities as per approved procedures, ensuring system integration and operational readiness. Performance acceptance test. Conduct PAT for a continuous period of 1 month under normal operating conditions, ensuring system performance meets requirements. PAT certificate and warranty of systems. Document test results in a PAT certificate and ensure warranty coverage for all systems until successful PAT completion. Guarantee and warranty. All systems and subsystems supplied by the system integrator shall be guaranteed for a period of 1 year. The system integrator shall ensure mechanical design, material, workmanship, and performance requirements are met. Promptly correct defects at no additional cost. Guarantee that all work meets sound engineering and construction practices. Transfer warranties and guarantees to the company upon system handover. Training. The system integrator shall provide comprehensive training for company personnel on all systems. This includes training for system implementation, maintenance, operation, and administration. Training for engineers, system operators, supervisors, and system administrators. Covering system components, functionalities, programming, maintenance, and spare parts management. Conducting hands-on training at the end-user site or at sub-supplier training centers. A comprehensive training plan shall be submitted for review and approval, covering operation procedures, maintenance procedures, configuration of software, safety precautions and guidelines,